Welcome one and all to Tungolana classes. Now in this class we will discuss basic concept in optics and what are sign conventions in optics. In detail we will see. So let us start. What are basic terms in optics? These are the terms which required very important in case of ray optics that we will study for the further study of reflection of the light. Before that, just I want to remind what we have discussed in the last class. In the last class, mainly we are discussing about spherical mirror and image. Spherical mirror can classify into two categories. One we are calling concave spherical mirror and convex spherical mirror, and we have studied the concept of image. Right. Again, image can classify into two categories. One we are calling real image, and second one we are calling virtual image. Right. Now, basic terms in optics. To understand the concept of basic terms, either you can take concave mirror or convex mirror. But taking any one mirror, you can study in detail what are basic terms in optics. First basic term is nothing but pole. First basic term is nothing but pole. What is mean by pole? That we will see. Simply to understand concept of pole, again we will take a mirror. Let us take this, we are calling concave mirror. See here, simply I can call this is concave mirror. Say it bulging part is silvered, and different part is reflecting one. Pole mean the center of spherical mirror. This we are calling center of spherical mirror. The center of spherical mirror simply I can call pole. Pole mean the center of spherical mirror, simply I can call pole. Right. Next, when after pole, we need to discuss what is mean by principal axis. Principal axis. Principal axis. Principal axis mean the straight line passing through pole on either side, that we are calling principal axis. Very simple. The center part of the mirror that we are calling pole. Simply this pole can be represented by quantity P. The straight line passing through pole. Straight line passing through pole. This I can call principal axis. This I can call, say this principal axis shall represent, this can be represented by xy. Xy is nothing but principal axis. Very simple. The straight line passing through pole on either side of the mirror or from the mirror, that we are calling principal axis. After principal axis, we need to study one more term. One more term, that we are calling center of curvature. Center of curvature. Center of curvature represented by quantity C. C, center of curvature. See here. To understand this concept of center of curvature, I would like to take a point. Look at me. What you are calling spherical mirror? Spherical mirror is a part of spherical reflecting surface. Already we know. See here. If I take this spherical mirror, then this becomes sphere. Are you following me? This becomes a sphere. Right on this. Right. Then simply I can take this is point. This is point. This point I can call C, where C we are calling center of curvature. Center of curvature means the center of a sphere. Center of curvature is the center of sphere of which spherical mirror forms a part. This is spherical reflecting surface. For spherical reflecting surface, if I take one of the part, that part becomes concave mirror. Right out of this. Then what is center of curvature? Center of curvature is the center of sphere of which spherical mirror forms a part. Spherical mirror forms a part, that we are calling center of curvature. Remember this. This point I can call center of curvature. How it is? Center of curvature simply. Center of curvature is the center of sphere of which spherical mirror forms a part. Say how to define? How to define center of curvature? The center of sphere or it is the center of sphere. It is the center of sphere of which spherical mirror forms a part. Spherical mirror forms a part that we are calling center of curvature. After center of curvature, let us define one more term that we are calling radius of curvature. Radius of curvature. It is represented by capital R. Radius of curvature. Simply what we know? The pole, the midpoint of the mirror or center part of the mirror, that we are calling pole, and this point we are calling center of curvature. Here what is radius of curvature? The distance between pole and center of curvature. Distance between pole and center of curvature. This we are calling radius of curvature. Are you following this? Radius of curvature. Distance between pole and center of curvature, that we are calling radius of curvature. How to define this? The distance between pole and center of curvature is called as radius of curvature. Radius of curvature. Radius of curvature. Right thing? Then let us define one more term. See here, one more term that we are calling, look at me, shall I write here? One more basic term concerned to optics, that we are calling principal focus. Principal focus. See here, principal focus, how to define? To understand concept of principal focus, now again I will take concave mirror. On concave mirror, if number of rays of lights meet and after reflection, how they will meet? Look at here. Simply I can take, this is nothing but one concave mirror. On the concave mirror, shall I take one ray of light? This is one ray of light. After incident, how it is? After incident, this ray of light can reflected like this. Right or wrong? Let us take one more ray of light incident here. After incident, this ray of light can reflected like this. In this manner, this ray of light can reflected. Are you following? This ray of light can reflected. Let us take one more ray of light. One more ray of light, it can meet here. After incident, again this ray of light can meeting at this point. Right. After reflection, all the rays of lights meeting at this point. This point I can call. This point simply what I can call, this point is nothing but focus. I mean, after reflection, the rays of light appear to be meet at this point or exactly meet at this point. Now, second situation I will take. Simply I will take. Now, this is nothing but what concave mirror. Shall I draw supply diagram for it? Look at me, how it is. This is nothing but concave mirror. This part I can call silvered. Right. This I can call center part of the mirror, this we are calling pole, and a straight line passing through pole, this we are calling principal axis. Right. This I can call center of curvature, represented by C. Distance between pole and center of curvature called as radius of curvature. Now let us take, this is the ray of light incident at this point. Right. After incident, this ray of light can reflected like this. Let us take one more ray of light. This is one more ray of light incident at this point. After reflection, this ray of light can bounce back like this. Let us take one more ray of light. From this point I will take one more ray of light incident. Again after incident, This ray of light can reflect like this. Like this can reflect. After reflection, number of rays of light meeting at this point. This point I can call focus, right? Second situation I will take. Look at me. Again I will take concave spherical mirror. This I can call concave spherical mirror. This part I can call silvered, right? Center part of the mirror, this we are calling pole, right or wrong? Now let us take this is nothing but straight line passing through pole. This we are calling principal axis. How to take? Let us take one ray of light. How it is going? Ray of light incident at this point and can reflect it back. Let us take one more ray of light. It is passes like this. I will discuss regarding this point. Right. One more ray of light. How it is going? Like this. After incident, it can reflect like this. But if the reflected ray they diverge, all divergent ray of light appear to be meet at this point on principal axis. All the ray of light appear to be meet on principal axis. This we are calling focus. What is focus? Principal focus is the point on principal axis. It is the point on principal axis where the ray of light meet or appear to be meet. How it is? Principal focus is the point on principal axis where the ray of light exactly meet or appear to be meet. That point we are calling focus, or that point we are calling principal focus. Very simple. How it is? Now this point I can call focus. This point I can call focus. Later on this. After principal focus, now we need to discuss one more point. That point we are calling focal length. That I can call focal length. Focal length can be represented by quantity f. Right? What is focal length here? This I can call pole. This I can call principal focus. The distance between pole and principal focus, this we are calling focal length. Are you following? The distance between pole and principal focus, this we are calling focal length. Simply, the distance between pole and principal focus is called as focal length of the given surface. Focal length of mirror, focal length of a lens. Right? See here. How to define this focal length? Look at me. I define principal focus in what way? The point on principal axis where the ray of light meet or appear to be meet. That point is called as principal focus. Then what is focal length? Focal length, the distance between pole and principal focus. Distance between pole and principal focus. And principal focus. Principal focus is called as focal length. Is called as focal length. Right? I define some terms. One is pole, principal axis, center of curvature, radius of curvature, principal focus and focal length. One more that we are calling aperture. One more term we will see regarding this. See here. That term is nothing but aperture. Look at it. Shall I define? See here. Next term, concern to basic term is nothing but aperture. 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 Again, we will take a concave mirror or convex mirror. See here. I would like to take this is concave mirror. This part is nothing but silvered. Right around this. Aperture means the average area available for reflection of light. This is the area available for reflection of the light. This area we are calling aperture. Simply, whatever average area available for reflection of the light, that we are calling aperture. Then after aperture, again we need to study one more term, that is nothing but object distance. Object distance. Second one is image distance. Image distance. These are very important to study reflection or refraction of the light. Students, again you will take this nothing but mirror, concave mirror I take. Then center part of the mirror, this we are calling pole, right or wrong? Center part of the mirror I can call this is pole. The straight line passing through principal focus, straight line passing through pole, this is the straight line passing through pole. This I can call principal axis. This I can call principal axis, right? Now we know that, let us take in front of the object or in front of the mirror, let us take one more object is situated. How it is? Let us take, I can take, this is one object, say this object I can take AB. AB is nothing but one object, right around this. Now what I can call, this I can call center of curvature, C point, right around. Now let us take one ray of light, this is the ray of light incident at this point. After incident, how the ray of light is going? The ray of light is going like this, reflected like this. Let us take one more ray of light, how it is? One more ray of light incident at this point and get reflected back. Remember this point. Remember this point. Now let us take one more ray of light, how it is? One more ray of light shall I take? This is nothing but one more ray of light incident at this point at principal focus, right around. How it is going? How it is going? Let us take this ray of light is going like this. For my convenience I will take, shall I take? This ray of, after incident, this ray of light is going like this. One more ray of light from this, not I will, from this point. From this point shall I take? From this point one more ray of light is going. So after incident, how it is going reflected? Let us take this ray of light is reflected like this. Remember this point. After reflection, all the rays of light are meeting at this point. This point I can call focus. Right around this. Then distance between pole and principal focus I can call focal length. Distance between pole and center of curvature I can call radius of curvature. What I can call? Radius of curvature. What is object distance here? Question is, the object distance can be represented by U quantity. Object distance can be represented by U. What is object distance? The distance between pole and object. Distance between pole and object is called as object distance. So in this figure PA is equal to O. And O, or you can PA is equal to U. This I can call object distance. Right thing. Now let us take one more term that we are calling image distance. Next one is image distance. How image appear that we will see. Separate diagram I will take. Look at here. For my convenience I can take separate diagram for it. See here. How this is. How the image can appear on the given mirror. Shall we take this? Again I can take concave mirror, this is concave mirror, this is reflecting surface, right? This I can call principal axis, this we can calling pole, right? Where object is available, consider object is available here. Let us call this object is AB, this object is AB. Now from this let us take one more ray of light incident at this point. After incident, how the ray of light can reflected? Ray of light can reflected like this, right arrow. Now let us take this nothing but one ray of light that is passing through principal axis. Now shall I take one more ray of light? Let us take one more ray of light incident at principal focus. After incident, how it goes? After incident, the ray of light can reflect like this, right? Now I can call this is center of curvature C. Let us take one more ray of light that is passing from center of curvature. Shall I take this point? This point I can take. So one more ray applied that is passing through center of curvature and it goes in the same path. I mean retraces its path. Retraces mean it incident like this. After incident it goes like this. Same path. After reflection where the rays of light meeting at this point. So simply this point I can call, this point I can call focus. What I can call? This point we can call in focus. After reflection all the rays of light meeting at this point. This point is nothing but A dash. Then how to take the image, that is important. How to take the image? If I draw this line, this indicates image. Where this image is equal to what value? That can be represented by A dash B dash. The rays of light starting from this point, after reflection all the rays of lights are meeting. This we are calling image. Right? Image appeared at in front. So this we are calling real image. That is different. Look at here. Now distance between pole and object I can call object distance. Where image appeared at B dash point. Then what you are calling? Distance between pole and image. This we are calling image distance. How it is? In this figure I can call P B dash is equal to V. That we are calling image distance. And distance between pole and object, that is PA. PA is equal to what value? Object distance. Very simple. What is object distance? Distance between pole and object is called as object distance. On other hand, distance between pole and image is called as image distance. Remember this point. So these are basic terms required to study reflection of the light. Then after this, what are sign convention in optics? Sign conventions in optics, that we will study. Before that, how reflection of the light takes place on concave mirror and convex mirror, that we will see. See here. Now next concept is sign conventions in optics. Sign conventions in optics. Look at me. Sign conventions in optics. Sign conventions in optics. Right? What are sign convention available? To understand this again, initially we will take concave mirror and convex mirror. For concave and convex mirror, how image can appear, that we will see. Look at me. Before that, shall I take concave mirror? I can call this is concave mirror. Simply you can call this is concave mirror. Right? A line passing. This is the line passing. Straight line passing through pole. I can call this is pole. This we are calling pole. The straight line passing through pole, this we are calling principal axis. Right around this. What I called? I can call this is center of curvature C. Right. A ray of light incident. How the ray of light incident? Ray of light incident like this. After incident, a ray of light must be reflect like this. In this direction. In this direction. Right. Again one more ray of light. How it is? Let us take one more ray of light. One more ray of light incident at this point. After incident, how it is reflected back? It can reflect it back like this. Look at me. Must be like this. Reflected. This point what I can call? This point I can call focus. Right. Distance between pole and focus. This we are calling focal length. Represented by F. Now, convex mirror I will take. Convex mirror. Simply shall I take convex mirror? This is convex mirror. This part what you are calling silvered, through which ray of light is not passes. Right. I can draw this. This I can call center of the mirror. So simply I can join this. This we are calling principal axis. This we are calling pole. This I can call pole. Here how the reflection of the light takes place, that we will see. How it is? A ray of light incident, it get reflected back in the same medium. A ray of light incident and get reflected back in the same medium, like this possible. And let us take one more ray of light is passing, that never deviated. But a ray of light actually they can reflect it back and they get diverge. They get diverge. All the ray of light, how to appear to be meet? All the ray of light appear to be meet at this point. Meet at this point. This point I can call focus. Later. Distance between pole and principal focus, this we are calling focal length. This I can call center of curvature C. Now we'll discuss. Now we'll discuss what are sign conventions in optics. See here, sign convention in optics are, first sign convention is all distance measured from pole. What it is? First one is all distance measured from pole. All distance measured from pole. Which is pole? I can call this is pole, this is pole. Whatever distance we are, distance mean either you can measure object distance, you can measure center of curvature, you can measure radius of curvature, you can measure focal length. See here. Distance between pole and principal focus we are calling focal length. All distance must be measured from this point. Distance between pole and center of curvature we are calling radius of curvature. All distance are measured from this point. We are calling this is pole, right? All distance must be measured from pole. Either we are measure center of curvature, you can measure principal focus, or you can measure focal length. What is first sign convention? All distance must be measured from pole. Second one is along the direction of incident ray. Along the direction of incident ray, all the distance are measured to be positive. Opposite to direction of incident ray, all distance are measured to be taken to be negative. I mean, along the direction of incident ray, all distance are taken to be positive. Opposite to direction of incident ray, all distance are taken to be negative. See here. Second point is along the direction of incident ray. Along the direction of incident ray. Along the direction of incident ray. Direction of incident ray. Incident ray. All distance taken as positive. Taken as positive. On other hand, opposite to direction of incident ray. 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 All distance taken to be negative. All distance taken to be negative. Taken to be negative. See here. Let us discuss this point. Along direction of incident ray, all distance are taken to be positive. How it is? See here. A ray of light must be goes like this. Are you following this? Along direction of incident ray, all distance are taken to be positive. How to take positive? See here. This is the direction in which the ray of light incident. What is first sign convention? All distance must be measured from pole. Look at me. Along the direction of incident ray, all distance are taken to be positive. Positive mean how it is? Distance between pole and principal focus we are calling focal length. Along direction of incident ray, all distance are taken to be positive. Positive mean in this diagram how to take? Distance between pole to center of curvature is called as radius of curvature. Radius of curvature taken to be positive because along the direction of incident ray. Second one, distance between pole and principal focus. What it is? Distance between pole and principal focus we are calling focal length. Focal length also taken to be positive. Very simple. Along the direction of incident ray, all distance taken to be positive. all distance taken to be positive. On other hand, opposite to direction of incident ray, opposite to direction of incident ray, all distance are taken to be negative. See here, in what direction ray of light goes? Now look at this figure. In this direction ray of light goes, in this direction ray of light goes, in this direction ray of light goes, opposite to incident ray, opposite to incident ray, all distance are taken to be negative. Opposite mean distance between pole and center of curvature. In this diagram, distance between pole and center of curvature called as radius of curvature. Radius of curvature taken to be negative because ray of light comes like this. All distance you are measuring in this direction, opposite to direction of incident ray. Later on this ray of light comes like this, your measure distance from this point, opposite to direction of incident. Similarly, distance between pole and principal focus, principal focus is called as focal length taken to be negative. What is second point? Along the direction of incident ray, all distance are taken to be positive. Opposite to direction of incident ray, all distance are taken to be negative. Second point. Third point, third sign convention, upward distance measured perpendicular to principal axis taken to be positive. How it is? Upward distance measure perpendicular to principal axis taken as positive. On other hand, downward distance measure perpendicular to principal axis taken as negative. What it is? Upward distance measured perpendicular to principal axis taken to be positive. How it is? Shall I take again mirror? I can take this is mirror, this is principal axis. Upward distance measured perpendicular to principal axis taken to be positive. Whatever distance you are measured, simply the upward distance measured perpendicular to principal axis taken to be positive. On the other hand, downward distance measured perpendicular to principal axis taken to be negative. Very simple. Three sign conventions are there. What it is? First one is, all distance must be measured from pole. Either you are measure object distance, you can measure image distance, you can measure principal focus, you can measure radius of curvature, you can measure center of curvature. All distance must be measured from this point. Second one is, along the direction of incident ray, either you are object distance you can measure, image distance you can measure, radius of curvature you can measure, principal focus you can measure. Whatever distance measured along the direction of incident ray, all distance are taken to be positive, and opposite to direction of incident ray, all distance are taken to be negative. Second point. Third point is, the distance measured upward perpendicular to principal axis taken to be positive, distance measured downward perpendicular to principal axis taken to be negative. These are sign conventions. But we are using some conventions, some rules in optics. Rules is, along the direction of principal axis, this we are calling principal axis. Are you following? Along the principal axis, the ray of light is never deviated. It is one of the convention. What is convention? Along the principal axis, ray of light is never deviated. For example, see here, I can take, this is nothing but one mirror I can take. So this we are calling principal axis, this we are calling pole. Along direction of principal axis, if the ray of light is passing along the principal axis, that ray of light is never reflected, ray of light is never refracted. Instead, ray of light is passes straight line. It is only assumption. It is first assumption. Second assumption is very important. Whatever angle of incident, whatever angle of refraction, those are assumed to be very, very small. Those are assumed to be very, very small. Here two assumptions will made. Ray of light which is passes through principal axis, never deviated, never reflected, never refracted, it goes in the straight line path. Second convention is whatever angle of incident, whatever angle of refractions, those are assumed to be very, very small. And whatever sine of angle of incident, tan of angle of incident, cos of angle of incident, all must be taken to be very, very smaller. These are two sign conventions. On these two sign convention, we will study the further relations. What is the relation between radius of curvature and focal length? What is the relation between object distance, image distance and focal length? That we will study in the further class. Thanks, students.